All right, so today we're going to talk about prime factorization, and we're going to review what you guys know about prime factorization. So let's start with the basics and start with the definitions. A prime number. A prime number is a whole counting number greater than 1. It has exactly two different factors, 1 and the number itself. So if we take a look at 3 here, we know that 3 has a factor of 1 and 3 and nothing else. So it has exactly two factors. 4, we know, has the factors of 1, 2, and 4. So being that it has 3 factors, it's not a prime number. 5 has the factors of 1 and 5, and that's it. That makes 5 a prime number. 6, 1, 2, 3, and 6. Nope. Is 7 a prime number? Let's take a look. 1 and 7. Yep. 8? Nope. 9? Nope. So a prime number is a number that has only two factors, 1 and itself. It's important to remember that 1 is neither a prime number or a composite number. So a composite number is a counting number that has more than 2 factors. So let's take a look at these again. So we know, 3, we figured out prime number. It's only 1 and 3 has only 2 factors. We want more than 2 factors. So nope. 4, we have 1, 2, and 4. Yep, we have more than 2 factors. 5, prime number. 6, 1, 2, 3, 6. Those would be our factors, right? That makes this a composite number. 7, prime number. 8, we know that has many factors. 1, 2, 4, and 8. Yep. 9, 1, 3, and 9. Yep. 11. Can anyone think of anything that goes into 11 other than 1 and 11? I can't. Nope. 12. Yep. 13. No. 15. Yes. 16. Yes. 17. No. 18. Yes. The circled numbers are all composite numbers because they have more than 2 factors. So now that we know what a prime number and a composite number is, we're going to look at prime factorization. So factoring a composite number to get a final answer of all prime numbers. So 24 is a composite number, but we want to get it down to prime numbers. So we start off by doing it with the number 2, which is the prime number because its only factors are 1 and 2 are, then we go 2 times what equals 24. 2 times 12. Here we go, 12. Now we break 12 up because we can't do anything more with 2 because that's a prime number, so we're happy with that number. But we want to keep going. We want prime numbers. 12 is a composite, so break it down. So we'll stick with that prime number 2. 2 and 6. 2 times 6 equals 12. 6 is a composite number, so we keep going. Start with that 2. 2 times 3 equals 6. Now let's check. Do we have any prime or do we have any composite numbers left? We've got prime, 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 prime. So we're happy with this answer. So as a final answer, we would write 2 times 2 times 2 times 3. It's a prime factorization of 24. Let's try this again with 16. So we have, we'll start with 2 again because 2 is a happy prime number. We like that number. So 2 times 8 equals 16. 8 is a composite number, so we break it down. We like our 2, so we'll keep with that. 2 times 4 equals 8. 4 is a composite number, so we keep going. 2 times 2 equals 4. So now we have all prime numbers. So we're happy with this. So we want to write a final answer of 2 times 2 times 2 times 2, because we have 1, 2, 3, 4 2's. So we show that down here in our final answer. That is a prime factorization of 16. Now let's look at the prime factorization of larger numbers. It's pretty easy with the smaller ones, but it can get pretty lengthy with our bigger numbers. Let's go for 40 right now. Starting with 2. Our happy 2 prime number. 2 times 20 is 40. And then we have 2 times 10 equals 20. 2 times 5 equals 10. Do we have any composite numbers left? Let's check. Prime, 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 prime. So we're set to go. Now we write our final answer. 2 times 2 times 2 times 5. So that's our final answer. That's our prime factorization of 40. Next, let's try it with 54. So we'll start with 2. What's half of 54? Let's see here. Half of 50 is 25. So 26, 27. 2 times 27 would be our first step in factoring 54. Next, we break down 27 to prime numbers. Next, 2 doesn't go into 27 because it's odd. So check if 3 goes into it. And 3 goes into 27 9 times. So 9 is a composite number, so we'll keep going. We get 3 times 3. So now we have all prime numbers, and we're set to go. So we write 2 times 3 times 3 times 3. That's our final answer for prime factorization of 54. So now I want you guys to try the prime factorization of 81 on your own. Pause the video and try breaking it down, starting with 2 or 3 with your first number. All right, so let's take a look at our final answer for 81. So we know that 2 doesn't go into 81 because, well, it's an odd number. So we took 3, and 3 times 27 equals 81. You know that 27 is a composite number because of our last example. We know that we've got 3 and 9. We get 3 and 3. So now we're happy with our prime numbers. So we write our final answer. 3 times 3 times 3 times 3. So when we're working with bigger numbers, a lot of times it gets repetitive. We have 3 2's, or we have 3 3's, or we have 4 3's. So what we do to save some time and make it a little more clear is we use exponents. You guys know exponents a little bit, but let's review it first before we start implementing exponents into our prime factorization. So 2, the big number is the base, and the smaller number is the exponent. So what this means is we take the base and we multiply it by itself 3 times. So it's 2 times 2 times 2. That is what this exponent right here says. We do not want to do 2 times 3. So let's take a look at our answers. 2 times 2 times 2, we get 4. Then we get 4 times 2 again, and we get 8. If we take 2 times 3, we get 6. That it's not the same. This is what we're looking for right here. Make sure you remember to do it this way. So let's practice this some more. 4 to the third power would be 4 times 4 times 4. Not 4 times 3. Let me say that again. Not 4 times 3. So 6 to the second power would be 6 multiplied 2 times. So we have 1, 2, 2. So that's our review with exponents. Now let's use our exponents with prime factorization. So let's start with 24 here. So we have 2, our happy prime 2 times 12. That's 12, it's composite, so let's break it down some more. 2 times 6 equals 12. Now let's break down 6. 2 times what equals 6? Well, we know that's 3. And now let's check to see if we have any composite numbers left. Nope, prime, 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 prime. So we're set to go. So if we write it in expanded form, we would write 2 times 2 times 2 times 3. But that's pretty repetitive. Let's use exponents. So we have the number 2. How many times? 1, 2, 3. 3 times. So we go 2 to the third power times 3. And that means the same thing as what's written right here. So this is how you would write the prime factorization of 24 in exponent form. So let's practice again with 54. We'll start with 2 because 54 is an even number and we can use 2. So 2 times 27. Now we break 27 down because we know that's a composite number. 3 times 9. And 3 times 3. We did this one already, so just reviewing. So we have our prime numbers right here. We get in expanded form, we write it 2 times 3 times 3 times 3. Got a lot of repetition here. So we'll do 3, 1, 2, 3 times to the third power times 2. And these mean the same thing, but this one, it's just a lot prettier, isn't it? So now I want you guys to try it out on your own with 81 here. First, do the prime factorization of 81, and then write it in exponent form. So pause the video and work it out on your own. All right, so this is our answer over here. So we've got 3, 3, 3, 3. We have 4 3s, so this one's nice and simple. 3 to the fourth power, because there's 4 3s. All right, that's all I've got for you guys. I look forward to seeing you guys tomorrow, and I hope this makes sense.